Completed problem 17. Let's take a look. In progress, is it? 17, yeah. So we completed problem 17. So we will continue on over here and let's look at problem 18. Today maybe we will do one or two problems again, and we'll see how long it takes, and based on that we will if we are able to solve this problem first, then we will just do that. Otherwise we will continue in the next on the next day. So this is problem 18. So let's start. Problem 18, we will call this problem 18, and this is problem 18. This is called the maximum path sum 1. Wow, okay, maximum path sum 1. And let's see what this says. What is this? Is this an emoji? A winky face? Okay, I'm already interested in this problem. Uh-oh. Okay, so it's not going to be very accurate, this. Okay, is this an image? Oh no, it's text. So I think there is a like a space over here, and 2 spaces over here, and 3 spaces over here. So it looks like that. And this is called a triangle, the top of the triangle below. Okay, we'll look at the problem later. Let's format this property first. And this looks like that. Okay, and let's see, this, that, okay. So we are on the path to create a triangle. All right, that's what it is. It's gonna take a while. Boring, but the problem seems interesting. Something about the problem with all the symmetry and everything. Okay, wow, rather interesting problem. Okay, so that's the problem. Why is my triangle not symmetric like that? I hate it. Never mind. Never mind. Okay, so what's the problem? By starting at the top of the triangle, so that's the, okay, let's look at this has color. By starting at the top of the triangle below, yeah, okay, and moving to adjacent numbers, so here or here, here or here, here or here, okay, adjacent numbers on the rows below, on the row below, the maximum total from the top to bottom is 23. Okay, that is 3 plus 7 plus 4 plus 9. So 3 plus 7 plus 4. Apparently, if you take this path, it will be maximum. If you take any other path, it will not be the maximum. Okay, find the maximum total from the top to the bottom of the triangle below. So this one. So we have to go from here to here to here, or here, 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 and then we have to figure this out. Okay. There are only 16,384 roots. It is possible to solve this problem by trying every root. However, problem 67, It is problem 67. It's a 15K text file containing a triangle with 100 result. Wow. Okay. Okay, this is humongous. Never mind this. Okay. Is the same challenge with a triangle containing 100 rows. It cannot be solved by brute force and requires a clever method. Clever method is what we do. So if we are able to solve this problem, we should technically be able to solve problem 67 as well. All right, so let's start. So let's see. Maybe I should turn on my iPad and connect it to this. So let me mirror my screen. Okay, and then all right, so there you go. That's my iPad. Let's start working on this. I think this problem is going to be interesting. So let's see. This one was my previous problem, and I am going to is this delete? Yeah, I'm going to delete everything, and let's look at this particular problem. So this particular problem seems to have a what the hell is this? Yeah, this particular problem seems to have a triangle, and we want to find the shortest path. So that's like a tree search, but I think I remember in one of the chess programs, to prevent the total number of paths from being too high, we need to create something where the paths are truncated. So what does this mean when it says that the paths, there are going to be too many paths? So if we start with 3, and then there is a 7 and a 4, and there's a 2 and a 4 and a 6, and an 8 and 5 and 9 and 3. So the idea is we should find a sort of recursive solution and the solution should be such that at any point it should not, the total number of paths should not blow out of proportion. So let's see. At this point, let me select another color. At this point, there is only one path. So if we look at this, there is only 3. This can go down to either 3, 4 or 3, 7. Okay, the sum of this is 10, the sum of this is 7. All right, then from this point, so it can either go here or here and create a sum that is 10, and this will create a sum that is 4 and 3, 7. All right, so that's the sum. Then this will go here or here or here or here. Okay, so up till this point, that's the only path you can take. All right, and this is the best path. From this point onward, the sum of this can be 12. The sum of this is either 14 or 11, and this one is 13, so it comes from here. Okay, so now at this point we don't care about this anymore, because anything from this point onward we only care about the biggest point. So this will come down over here, and this will be 20. This will come down over here, and this will be either 19 or 12 and 5 is 17. This one can come down from either way, and obviously I'm going to take the highest of this, so that's 14 and 9, 23. So that's the bigger path, and this will come down over here, that's 16, and we don't care about this. Okay, so that's the general way of solving this problem. Okay, I think it looks like the way to solve it. This is at any point n on for this is space complexity is on, and time complexity should be on. At each point we need to calculate 2n, like 2n, but yeah, it's on. So time complexity, space complexity is going to be on. So if we are able to solve this, we should be in this way, we should be able to solve this other 67, problem number 67 as well. Okay, so let's try to solve it. We are trying to do this in that particular way. So let's start with this thing over here, and let's call it Nonstring equals can I get this? All right, and split for row in left into row. Actually, theta equals yeah, row dot strip dot split print data. It will be that. Okay, so if data, so we don't care about the I press the caps at some point like that. If not data, so we only keep this, and this one data is int d or d in data, and that's pretty. And numbers is nums data, and let's look at nums. Nums. Okay, so this is the first thing. It has 3. Then we have 7 and 4. Then we have 2, 4, 6. Then we have 8, 5, 9, and 3. So if we substitute this, we should be able to create that over there. So now we go row by row, and we figure out what the maximum values are. So we keep on adding. So what we are doing is we are going to this row, and if there's only one value, it is what it is. If there is the next row, okay, so we start with the previous row and we go to the next row, and we, for each element, we take the one before and the after. So that's the, if this is the I equals 1 element, we need to take a look at I equals 0 and I equals 1. So the one before and the one after, the one before and the same one, I think. So let's take a look at it. For row in nums 1 onward, like that. Okay, and I will keep a previous row equals nums 0. Okay, and what we want to do is we want to take if it's the first one, it should take, or it should take the previous one and the first one, and if it's the first one, there is no previous one. Okay, I in enumerate like that. Okay, print. I just want to make sure that I am getting the right numbers. So we are in row I, okay, we are, we don't care about this, we don't need to enumerate this, we need to for C in I comma C in enumerate row, like that. Okay, and let's see, we are, let's just put our over here. Enumerate that, and let's see, we want to print R as well, R 3D, this can be 4D, and the value itself is C. Okay, so we have 7 and 4, and then for the next row we have 246, and then we want to associate it with the list of values. If I is 0, okay, then p list equals the same one. Oh wait, there's a better way to do this. v2 equals previous row, and we want to find the same one, and v1 if I is greater than 0, v1 equals the one row I minus 1, else v1 equals 0. Okay, so we want to print v1 and v2, v1 and v2 like that. This index out of range. If I is less than length of row, minus 1, then v2 equals I, else v2 equals 0. Does this work? So for 7 it's 0, 3 and 3, 0. Oh, I have to update previous row. Previous row equals row. That's that. So okay, so we are on this row 7 and 4, and for 7 we get 0 and 3, and for 4 we get 7 and 0. That's not what we want. We should get 0 and 4. for 2, 4 and 6, 2 should be 0 and 7, 4 should be 4 becomes 2 and 4, and 6 becomes 4 and 0. So this number is not correct. What about 8? 8 should be 2 and 0. 5 should not be 8 and 5. 9 should not be 5 and 9. 9 should be okay. If I is greater than 0, are we changing nums anywhere? No. Why is it so weird? 2 and 4. And okay. This is all going to change. Okay. So now, let's see. So now we have the right values. I need to add the maximum of this, which is max of v1 and v2, to this thing over here. So we will say can we just use, instead of doing this, can we just use curmax? And curmax. And current max. Oh, that's the reason why. Okay. So previous row is nums 0. Okay, so that's the previous row, and at the very end, previous row equals row, and we want to put previous row over here and previous row over here. And we want to really put current max over here. Okay, so for 4 it's 7 and 4, for 5 it's 2 and 4, for 9 it's 4 and 6, and for 3 it's 6 and 0. Okay, so now we have the right values. We want to create a temp value, and for each of these things we want to add, so when we are over here, it can come from either here or here, and we want to add this, the max of this and this to this, something like this. Append max of v1 and v2 plus c, and I can print temp. For 7 it's 10, for 4, so at this point it's, for 4 it's 7, so 4 and 3 7, we have this value. Okay, for 2 it's 9, for 4 it's 11. So yeah, so it's 11, it's this thing. And for 6 there is only one value. Okay, so that's what should be your, that is actually what should be your previous row. Like that. And the last one is 23. The maximum of this is 23. So that comes from this point, 14, the maximum 9 and 14. So 9 and 14 is 23, and it, okay, so, and then the max value equals max of row. That's the solution. Okay, so that's the solution for this problem, but we need the solution for this problem. Copy, and for that problem, right? And this one, Nonstring equals that, and that's nums, so it starts from 75 and it's 4 all the way to 23. Okay, and if we solve this problem, this is it's a pretty long problem. I don't know if I figure out that should be the solution. Let me see if that's the right answer. All right, which means if we go back to Project Euler, so we can say that we have been able to solve problem 18. Okay, so let's go back to problem 18. No answers, yeah. What we want to do is we want to go over here and so this is problem 67. It's the same problem, but the string is very big. So this is problem 67. Let us also solve this problem. Okay, because apparently you get 2 birds with 1 stone. Okay, so it's like that, and find the maximum total. So this is the text. Copy this entire thing and Nonstring equals like that. Okay, and let's say we do that, and we do that, which is some very big number, and then we do this, and that's the solution. Okay, let's try to solve this problem like that. So we solved 2 problems today. You are 976 blah 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 percentage, yeah, whatever. So we solved 2 problems. We solved problem number 18 and also problem number 67. Okay, so we are going to stop over here, and we will see you next time. I will upload this to YouTube, so if you like content like this, please like and subscribe, and see you next time. Bye bye.